Hi, I'm Mark Tewksbury, your host of this program. Our goal is to reveal the methods and materials that turn out the products you see in your everyday life. From toothpicks to airplanes, we'll look at them all. If you think you know something about those items, you might be in for a surprise. There's a whole world of things waiting for us to discover here on How It's Made. Did you ever wonder why, when driving at night, your headlights are reflected in the yellow or white paint that marks the road? The answer is simple. That paint has tiny beads of glass in it, making the lanes more visible and driving much more safe. On today's show, copy paper, jeans, computers, and plate glass. Do you remember hearing that with the advances in technology, we'd use less paper? Ha! I seem to be using more paper than ever before. Paper production begins with the arrival of wood at the mill. Paper is made from a paste produced from a mix of 65% maple, 25% birch, and 10% poplar. They require 2 tons of wood to produce 1 ton of paste. Everything starts from this debarking drum, which removes bark from the logs. It's about a 20-minute operation. The bark will be burned to produce steam, required for the operation of the mill. The debarked logs are transported on this conveyor. All is controlled by an operator. Now the logs are reduced into small pieces called kindling. They're accumulated into a pile and remain outdoors, winter and summer. The kindling looks like this. These 5 piles total about 30,000 tons of kindling. Next step, reduce the kindling into a paste. They begin by washing it. This screen verifies that the washer is properly loaded. Then comes alkaline cooking. This diagram controls its operation. This huge cylinder is the washer in which the kindling is cooked for several hours at a temperature of 158 degrees centigrade. And this is the recuperation boiler. It burns wood lignite at 1,000 degrees. Certain chemical products which come out fused as lava are recuperated. This black liquor, a residue of burned wood, will be burned to produce steam. Exiting the washer, the brown paste is washed and sent to the thickener. With this spatula, they verify the quality of the brown paste washing. The paste must be bleached. This alkaline extraction tower places the brown paste in contact with chemical products. It's bleached with chlorine dioxide and gradually becomes more white. Then the water is partially drawn off. This worm screw breaks up the paste so it can be pumped into storage reservoirs. Water is extracted with this equipment, the Bellois Belbay 3 paper machine, operating at a speed of 1,060 meters a minute. Between the entry and the exit, the concentration of water in the paste falls from 95 to 5%. Here we see the sheet of paper coming out of the presses. Then analyzers verify the quality parameters of the paper and signal any anomaly. The paper is then rolled up. This roller produces enormous main spools. With this transfer arm, they change a full spool for an empty one. A roll weighs over 35 tons and contains 60 kilometers of paper. The spooler cuts the main spools into smaller, less wide rolls. Some will be delivered as is, while others will be shipped to paper cutters. Rolls are sent to an automated warehouse. In the warehouse, they store rolls which will be cut later. Robots, guided on rails in the floor, feed the Beelomatic paper cutter. This is the one that produces copy paper. Robots are controlled by a central computer directed by operators. Production reaches 55,000 sheets per minute. We see here the transfer section of the cutter. 4 automatic catchers and operators verify paper quality before packaging. In 1 hour, this mill produced 6,600 packages of copy paper. A single log allowed for the production of at least 15 packages of copy paper. What was once the rugged garment material for factory workers, farmers, and tradesmen is today one of the most popular clothing items in the world. Yes, jeans are a fashion statement. Jeans are made from a highly rugged cotton called denim. This enormous roll contains 450 meters of fabric, from which they will produce 350 pairs of jeans. Several thicknesses of the material are unrolled on this long table. This knife can cut up to 100 thicknesses of the material at a time. By multiplying the thicknesses, they produce a whole pile of pieces with one cut. They shape the denim pieces following cutting patterns. Each piece of the jeans has its own cutting pattern. The little pieces of fabric are cut with a clicker, also known as the stamper, which cuts out pockets with a cutting mold. Exerting 1,500 pounds of pressure, it can cut 20 pockets at a time. They begin sewing. Jeans are sewn with 100% cotton thread. This needle pierces the fabric 4,000 times a minute. Designs are embroidered on the pockets with this machine. Its needles move at 2,500 strokes per minute. And this pocket robot will simultaneously fold, press, and sew a pocket. This machine allows for the installation of 75 pockets in 60 minutes. And the pocket is now sewn into place. Next up, the buttonhole. This machine sews the contours of the buttonhole, and a steel blade comes down to cut the opening. The closing button is positioned. This machine is used to make the loops, which will hold the belt in place. The loops are sewn, as usual, with cotton thread. At this stage, they assemble the different pieces of the jeans. This operator joins the 2 pieces of denim at the crotch. And then she sews it. Then they sew the exterior of the leg. This sewing is done flat with an overcaster which cuts excess material proportionately and to size. Now for the zipper. This machine installs the zipper holdfast and the slide. The zipper is sewn into position. The final sewing step consists of installing the jeans belt, a strip of fabric. This operation requires only a few seconds. The jeans were made up on the reverse side so that all stitches would be on the inside when the jeans are worn. The pant is then turned right side out with this turner, which has 100-pound suction power. All that now remains is to steam press the jeans. This operation lasts only 20 seconds and eliminates any pleats. This company makes 1,500 jeans every day. Producing a pair of jeans will have taken 12 minutes and 50 seconds of work and will have required between 1.1 and 1.2 meters of fabric. Can you imagine a modern household or office without this revolutionary device? The computer? I can't. It takes about 90 minutes to assemble a computer. Its hard drive disk saves information transmitted to it for a long time. The reading head reads the information. It is extremely precise. The space between the reading head and the hard disk is as thin as a hair. The hard disk is installed in its position within the computer. There are two other units which safeguard information: the removable 3-inch disc reader and the CD-ROM reader, which allows for the reading and execution of programs recorded on compact discs. These two units are placed into position. The spinal column of the computer is the motherboard. It is to this unit that the other elements of the computer are connected. This cooler dissipates the heat generated by the chipset. Certain sound cards are integrated directly on the motherboard. These connections, in sequence, are the audio input, its output, and the microphone port. This AGP retaining ring secures the video card during transport. This thermal unit measures the temperature emitted between the processor and the motherboard. The processor is the brain of the system. It interprets, calculates, and executes the instructions given to it. The processor has several millions of transistors, and its cadence, its operating speed, reaches the gigahertz level. The processor rests on this base. The processor's cooler dissipates the intense heat. Its efficiency depends on the type of material used, and a conducting material assures better cooling. The RAM memory stores short-term information, but erases it when the current is turned off. This memory is more rapid than that of the hard disk or the CD-ROM. Now they integrate everything in the case. It protects the internal elements from the external elements. At this stage, they install the electronic components in this case. Several connectors of the case are connected to the motherboard, such as the commutator and various light indicators. This is the output connection for the video card, which links the computer to the monitor. We also see the video chip, which creates images in 2 and 3 dimensions. Here is the video memory. The more its capacity is increased, the clearer will be the image displayed on the monitor. The video card is placed into its position. The modem allows two computers to communicate. Its condensers produce the perfectly clean phone signal to facilitate communications. These modem chip connectors control information circulating between the two computers. The fax modem is installed. The power supply transforms electricity according to the voltage required by the different components. The computer's interior cabling is installed. It allows information to travel between the different media and the motherboard. The IDE cable is connected and the CD-ROM. The last electrical wires are connected to different computer components. The assembly of 30 components of the computer is now finished. Just before closing the case, they test each computer to verify the good functioning of the peripherals. Then they close up and proceed to packaging. This company produces about 300 computer units every day. So clear, so perfectly flat, absolutely huge. But let's make it very clear. Manufacturing plate glass is anything but simple. We can speak of the use of glass since the time of the Egyptians 4,000 years ago. It wasn't used in construction though, but merely to enclose small objects. Later, the Romans became masters of glassmaking, with their methods being used up until the 18th century. By the end of the 19th century, glass was no longer just a luxury item, but became a construction material as common as steel and concrete. Plate glass is made from several raw materials mixed with a little water. These materials are silica sand, soda ash, dolomite, limestone, nepheline syenite, and salt cake. It begins by dumping into a hopper pieces of recycled glass together with the raw materials. It will all be melted. In a continuous stream, the mixed materials go into a gas-fed furnace. Temperature inside the furnace is 1,500 degrees centigrade. It contains 1,500 tons of molten glass. They use 500 tons of it every day. In this regenerating chamber, combustion air is preheated to 1,000 degrees. The materials of the mix begin fusing, and the molten glass is stirred up. The homogenizer mixes the glass to equalize its temperature. Pouring will be done within several hours. In the glass industry, they call this machine the top roller. The glass is poured onto a bath of liquid tin on which it floats. As soft as toffee, it's molded into a ribbon. All equipment in the tin bath is cooled with water so that it won't break from the heat. Coming out of the bath, the glass is at 600 degrees. The glass must again be cooled, and this unit is used to do that. This huge ribbon of glass is 3.3 meters in width. The ribbon of glass rolls gently on rollers, gradually cooling along the way. The glass is still soft. The marks we see are imprints made by the top roller. The glass must have a uniform thickness. This laser scanner measures its thickness to within 1/100th of a millimeter. The glass is now fairly hard. They proceed to cutting it. This ultra-hard tungsten carbide roller makes a longitudinal score before the glass can be cut. Now they proceed with transverse scoring, made according to the dimensions customers have asked for. The scored glass separates easily. The glass strips are separated and continue along on the conveyor. These roller breakers cut the edges of the glass sheet. Leftover pieces fall to the ground and into a chute. They will later be recycled. These rubber-covered rollers convey the glass sheets to the inspection department. When they arrive for inspection, these immense glass sheets are handled with great care and are positioned upright. The glass is inspected for faults with fluorescent lamps. Once inspected, the glass sheets are handled one at a time and stored vertically. Making the glass took several days of work. It is now ready for delivery. Heat fusion has transformed solid ingredients into transparent glass. If a picture's worth 1,000 words, I hope what you saw today speaks for itself. Our goal was to give you a view of the many manufacturing methods that produce the things we see in our daily lives. I'm Mark Tewksbury. See you next time on How It's Made.